And in some community, cassava is the only staple food. In countries like Congo, cassava leaves is consumed and it's a big business there. And cassava yield can be between 25 to 40 tons per hectare under normal circumstances, but unfortunately in Africa, yields of cassava are very low, mainly because of two viral diseases, cassava mosaic disease and cassava brown streak disease. Cassava mosaic disease was described in Tanzania in 1894. In the foothills of Usambara mountain, it's caused by virus and is transmitted by insect, Bemisia tabasi, when they feed on them. And also when farmers plant infected cuttings. So these are the viruses, about 9 species. So yield of affected plants look like this, and the photosynthetic system is completely disrupted, and therefore, instead of you harvest very tiny roots like this, instead of this. So another disease is cassava brown streak. Again, it was described in Tanzania in 1932. It's caused by another virus called cassava brown streak, but it causes rotting of roots, and therefore farmers cannot sell or eat. And also we found, through another research, we found novel DNA that were found integrated in cassava genome. They also enhance the disease and break resistance. Losses are huge in terms of money and tonnage. So this photo here shows households with very little cassava there because of the viruses. So to manage these diseases sustainably, we needed to have local capacity in Africa in place to diagnose them, but also that are simple, cost-effective, and robust enough to be used in our country. The diagnostic capacity in sub-Saharan Africa before 2005, it was characterized by little funding, lack of trained people. So we used to collect sample and then send them to US or to advanced labs. This photo up there, that was me. You can see in a guest house somewhere in Lindi, collecting samples, doing DNA extraction, and then we moved with the sample to US for further analysis. And sometimes we ship the samples by FedEx. So we approached the donors, BMGF, Rockefeller Foundation, and the others, to request for funds to build local capacity in Africa. So we got money and we built capacity in 7 countries. So this was a 10 years program. And so the countries are Tanzania, Kenya, Uganda, Rwanda, Malawi, Zambia, and Mozambique. So the broader objective was to boost the productivity of cassava by diagnosing these diseases. So we had 3 components: understanding the viruses, also supporting clean seed system, and building capacity in terms of human and the infrastructure. So the achievements, so we had a network of scientists working together using harmonized protocols and the standards to address this problem. So we built capacity, we built labs. That's a lab in Zambia, and screen houses also in Rwanda, Musanze there. This is a lab in Mozambique, Maputo. That's a lab in Kenya, Jomo Kenyatta University there. And the equipment, this is a lab in Malawi, lab in Uganda, and lab in Tanzania at Mikocheni with the facilities that were there. And then we in terms of capacity building, human capacity, we trained scientists, many scientists on how to do, to collect, to do disease surveillance, generate maps, and use the maps to decide on where to deploy planting material. These are our young scientists who graduated through the programs. So then we generated maps. Each country generated maps, and we used the maps to decide where to deploy material so that only correct disease-resistant material were deployed in correct areas. So also we identified the viruses using advanced DNA sequencing techniques, and these are the maps that were generated. Don't worry about this. And then the biggest question was now, how do we connect science, technology, innovation with smallholder farmers to make impact? So you can see on one side we have these farmers with the food shortage, and then we had advanced labs there. So we had to connect by ensuring that all farmers receive virus-free planting material. And we engaged all these stakeholders, farmers, NGOs, regulators, etc., so that we could reach farmers with clean planting material. So if you zoom here in Tanzania, this is a situation in Mara region before the intervention. You can see all the cassava material there are diseased. Yield was very little, less than 5 tons per hectare. So we went there, collected samples, we analyzed in the lab, and we sent them correct material that are resistant to viruses that were found in those areas, in collaboration with breeders. So that is farmers in Mara, Utiama, they are receiving material that were already tested in the lab that were disease-free. We planted together using appropriate agronomic practices, and that is 2 months after establishment, and you can see the fields are looking very clean, you can see, and yield is huge. So we boosted yield from less than 5 tons per hectare to 45 tons per hectare. And farmers, you can see this farmer now, these farmers are selling those material to other farmers to get money. And it was huge impact in terms of boosting income, nutrition, etc. These are different, we engaged students also. These are farmers celebrating. In Rwanda, we had a similar problem. Before the project intervention, you could see the disease was, incidence of disease was very high, but we provided them with clean planting material that were tested in the labs that we built in Rwanda. And we planted together. This is 9 months after planting, and you can see huge yield, about 45 tons per hectare. And those who have been to Rwanda, I think you see the government took up this initiative and distributed all this material throughout the country. But they went to Brazil and got an investor who came and built a very huge cassava facility at Kanazi. And that was a market for them, and they are producing cassava flours. In Zambia, the situation was like this before project, and we went and gave them clean planting material, tested in their the labs. Yield was huge. In Uganda, this was the situation before project. These are the clean material, and you can see 45 tons per hectare. And yield was huge. Over 1,000 farmers benefited from this material. In Kenya, the same. In Malawi, you can see very clean seed material, and yield was huge. In Mozambique, again the same. We had very good impact. So the point here is you can see how farmers have benefited from science. Case 2 is application of genomic tools for sustainable management of insect pests. We know that one of the biggest problems affecting crop productivity in Africa is the persistent occurrence of insect pests. We have pests like fall armyworm, which is a serious problem, has affected a lot of yield in maize, as you can see in these photos. And using pesticide, insecticide, they work in some conditions at the some stage of the insect, but they don't do well under some stages of the insect. We have aphids, also is a big problem. Tuta absoluta, najua kantangaze, destroying a lot of tomato. It's a serious problem. Then white fly, they damage crops and transmit diseases. So how do farmers respond to insect pest infestation? Extensive use of pesticide, phytosanitary weeding, use of improved variety, sometimes unsuccessful control. And because of that, farmers try to combine different insecticides, which is not good, costing them economically and not healthy to the environment. Now, the reason is, so using genomic tools, this advanced DNA sequencing, we can use them, we could use them to go into the insect and understand their genetic diversity. Because when you look, this is insect, these are white fly. Visually, they look the same. But when you fingerprint them, DNA fingerprint them, you find that they segregate into different genetic groups. And each genetic group responds differently to different insecticide. So you can be having insecticide which is recommended for white fly. But if it is efficient against type 1, it will not be efficient against type 6 of the same insect the same insect. And that is when the people say, oh, this maybe is a fake insecticide. No, it is not fake. It is insecticide that had been applied in a wrong genetic group. So the role of these genomic tools is to identify the biotypes of various insects so that correct insecticide is deployed in a correct area to control correct insect. That is when you have sustainable management of this insect. Look at the fall armyworm, they look the same genetically, they are different. A tuta absoluta, you have two genetic groups of tuta absoluta, group A and group B. Group A, all insecticide in the family of organophosphate, they don't work well, but in group B, they work well. So, mealybug is a serious problem, but again, they segregate into different genetic groups. So, using this technology, we are able to identify these groups and deploy correct insecticide to control them. This is just the same insect, different insects caught in different crops. And they exist in different genetic groups. So eventually we generate maps like this one and guide us to make decision on where to deploy insecticide, where to multiply varieties, etc. So now, do we have this capacity in Tanzania? Do we have this capacity? Yes, we have. Previously, we were using this conventional conventional PCR machines, but now we have this portable DNA sequencers that you can use in the field without taking them to the lab. Previously it was developed to identify viruses like Zika and Ebola, but Tanzania, we became the first to use this technology in agriculture. The first in the world to use this technology in agriculture. And here is so these are publications that resulted from this. This is a photo where we launched this technology in Mara region. And these are publications from this. We went also to BBC to talk about this technology. And now it's being used in the whole world. The technology itself is very simple. It involves device like the mini iron where you load DNA samples, and then the DNA sample, when they pass to those nanopore, with the electric current, they make shift in electric currents, which is captured as signal, and it will enable you to sequence the whole, to give you whole genome of any organism. So that is when we're sequencing under the tree in Imara. You can see Maasai clothes there, and that in 20 minutes, farmers had all the results of viruses in their cassava.
Professor, how far are you to the end?
Not much.
Not much.
Yeah. That's why I'm moving. So this is the device, and it gave Tanzania a big award. And this technology also, we have used it recently for control of locusts, like identifying locusts in Dodoma, and we deployed correct insecticide using drone. This is in Mpwapwa, and we successfully controlled all the locusts there, and we saved crops from being destroyed by those who have not seen red locust, this is how they need, you see, they are unstoppable, they eat anything. Yeah, so we use the drones to control them. This is a award we received from there, from the work, but also TPHPA, that's Tanzania Plant Health and Pesticide Authority. We are also acquiring new aircraft for managing. These technologies, we have also used it to fast-track breeding, to identify genes like we have done it, to identify, to distinguish hybrids in oil palm, michikichi, using this technology instead of using conventional or manual technology. Because it will tell you clearly which is the hybrid and which are not the hybrid. Also, we have used this technology to identify gene for aroma in rice, and also gene for salt tolerant to confer resistant to drought and drought. So this information is available. We also used, set up genetic engineering lab at Mikocheni there, and we used this technology to transform cassava for disease resistance, and is something that was done by ourselves. So those who say if you are doing genetic engineering, we will depend on wazungus, it's not true. We can do it ourselves. Impact is huge from this work because we build capacity, we train our scientists, and we attracted a lot of collaboration and also resource. And we train our people who could have gone to abroad to train. They used this facility established in the region to conduct their research. Also, through this initiative, we initiated a similar program in West Africa. So we have 12 countries now running this similar project in West Africa. And also, we attracted a lot of collaboration in Spain, in China, and Australia, US. We went and also set up a laboratory in northern Nigeria at Kebbi State University. The last thing I want to share with you is using scientific knowledge integration. We were able, field like where we have integrated field like molecular biology, advanced DNA, RNA sequencing, molecular genetics, bioinformatics, mathematical modeling, computational biology, and genomics. We have been able to identify phytocompounds from various plants to address human health issues. And we have 109 products for different human diseases. The list is here. They can treat a number of diseases as listed there, including those which the world has declared that there is no cure. So this is a power of science, technology, and innovations. And if you learn from African visionary leaders like the Professor Thomas Odhiambo, he says Africa needs science, not just technology. And what is required in Africa is, in the future, is much more first-class science conducted by African scientists to solve the problem of African agriculture. And I think that is the way. But also, President Kwame Nkrumah said it is within the possibility of science and technology to make even sub-Saharan bloom into a vast field with agriculture and industrial development. So my take-home message is just one. With a catalytic power of science, technology, and innovations, Africa can transform its economy, for sure, become competitive and climate resilient. But for us to succeed, we need dedication, self-motivation, high-level cooperation, hard working, high-level of transparent. We need mindset change of our scientists. But we need also to train and value. Africa needs to train and value its scientists. It's not only enough to train and then you don't value them. They leave, they go and work in looking for green pastures in Botswana, America, elsewhere. So we have to value them.
Professor, muda wenu umeisha kabisa na zaidi.
This is my last slide. I would like to acknowledge
sawa kabisa.
The government of Tanzania for all the support, but also to all the partners, institutions working together, which we are working together, I mean government and the private sector, and to our development partners also. But we are also very grateful to our parent ministry, the Ministry of Agriculture, for all the support. And we thank also our farmers for allowing us to collect samples in their field, but for trusting us also. Thank you.
Thank you very much. Thank you very much, Professor Ndunguru. May I now call upon Professor Hamisi Malebo, who is going to be our moderator of the discussion. And in front of there, you have your discussion panel of discussants, and you are going to manage them and see how you can spend only 10 minutes which you have with you. Karibu mbele, Hamisi Malebo. Professor Hamisi Malebo, who is our moderator for the discussion, is actually an executive secretary of UNESCO, National Commission of the United Republic of Tanzania. For the period between June 2021 to 2024, he also got an appointment, presidential appointment of the Traditional and Alternative Health Practice Council in the country. Professor Malebo is holding a PhD in medicine phytochemistry that is acquired in 2009. With Professor Malebo, you have 5, we expected to have 5 of them, but you only have 3. Yes, we only have 3. This is Dr. Bwana, Dr. Jerimana, and Dr. Otieno from MUHAS. So, Professor Malebo, please, the floor is yours, 10 minutes. And you also give some chances to the audience. Karibu sana. Sorry, before you do that, I was given a piece of paper here from our side. Somebody owning a car with registration number 439 EHB. The windows are open, there are valuable equipment in the car, and it is tempting some other people to take them. So can you quickly go outside and see how you can manage your car, please? Karibu, Professor Malebo.
Asante sana. As we have all of us heard from the guru, Professor Joseph Ndunguru, you can agree with me that this was a hallmark presentation. He dwelled from agronomy, plant ecology, vector behavior, and vector genetic diversity with reference to their response to insecticides. I'm not going to repeat it because I cannot fit into his shoes, but I would like to call other gurus to start discussing and contributing to this important presentation. And it is my pleasure to welcome in the first place Dr. Thomas Bwana. Dr. Thomas Bwana is the Director General of Tanzania Agricultural Research Institute, TARI. He is an accomplished agricultural scientist and visionary Director General of TARI. He has a strong background in agricultural research and leadership. So, Dr. Bwana, just in summary, the floor is yours now. You are welcome. You can just speak from where you are.
Thank you very much, moderator, and thank you very much, the organizers, for inviting me here. This is a very important topic on trying to see how we can leverage science and technology in making sure that we have sustainable production in agriculture. And I will directly focus on the agricultural area, where we all know that when addressing issues of climate change, agriculture is both contributor but also is a victim of climate change. And in doing so, when we are trying to address climate actions, there is no way we can do that without embracing science and technology. This is very important, especially where we see that in doing our agricultural activities, there are areas where we contribute to climate change. For instance, when we are producing our rice production, we have a bit of emission of methane. And in TARI and in some other scientific institution, we are taking action where we try to control the flooding and making sure that we do the drying and the wetting. By drying and the wetting, we reduce the amount of methane that is emitted from the rice field, and then we contribute less towards climate change. But also in the tillage practices, where we try to see our tillage action and again the types of plant that we are planting, they are leveraging and enhancing the amount of carbon that we are sequencing. So we take action towards reducing the amount of greenhouse gases that we are contributing. But again, in making sure that our society, agricultural societies are resilient, we have to make a lot of effort to make sure that we come up with action and the technology that are helping in reducing vulnerability of our farmers to climate change. And this, we are doing it in the whole life cycle of the crop, from from the soil itself. So there is a lot of agricultural technologies that we invest in soil management to make sure that with the limited moisture that we have in the soil, farmers can capitalize on that and get enough moisture. And this then we link with the traditional knowledge, because in most cases in science, we always capitalize and build on the traditional technologies. For instance, in moisture conservation, here in Tanzania, we have the Matengo pits, where people, since ancient time, they used to use the Matengo pit to make sure that doing soil conservation, but again, we are making soil moisture conservation. So in soil, in the research science in TARI, we do a lot of tillage management, where we improve the capacity of the soil to produce more and more. But also, we are doing a lot of work in crop improvement, because of climate change, we know that now our crop are becoming more vulnerable to drought and the floods. So in TARI, we are doing crop improvement to make sure that we are coming up with varieties that are drought tolerant, but again, varieties which are pest and disease tolerant. So in crop improvement, we also do that. But also, we build on the capacity or the traditional knowledge that has been there since ancient time, because we know the farmers, since ancient time, they also had some technologies where they used to conserve seed, but again, they used to control floods. For instance, in seed technology, where farmers used to do the smoking, they reserve their seed for a year or two. So here in modern science, we also can capitalize on that and come up with technology that can make use of the ancient technology. We have a lot that we are doing, and for instance, in Tanzania, TARI and the scientific community has contributed a lot in the development of variety. For instance, in cotton, there is no variety that is grown in Tanzania that has not been developed in TARI and in Tanzania. The whole of the white gold that you are saying, it comes from the science that has been developed by our sons and daughters in Tanzania. Likewise, in the cashew nut, the whole of cashew nut, we have been enjoying the good price of cashew nut, but the cashew nut that is grown has been developed in TARI with our sons and daughters. So the capacity that we are having. If you come to rice again, we have improved some varieties, traditional varieties, but with modern variety, we came up with Saro 5, the popular one, all over the country, and you see that farmers are enjoying that modern technology.
Dr. Bwana, can you summarize it?
Yes,
just in
so in conclusion,
seconds.
because we don't have much time, the most important thing for me is that we have to embrace science. We should not avoid science. Let's capitalize on the traditional knowledge that we have with the modern technology that is emerging. Then we hybridize and come up with a right technology for sustainable agricultural production. Asante.
Asante sana, Dr. Bwana. Professor Ndungulu reminded me that I forgot to mention something, that we went to school together, and we were active members of the science club during our time, and we make a lot of impact, and we are continuing to make impact even at this age. Our next discussant, I would take the prerogative of the moderator. I would like to welcome Dr. Jemana Leina, the Managing Director of TFNC. She has wide experience in food, science, and technology. She has done quite a lot in policy and scientific research as regards to food. And as all we know that this is the major reason, that's why we are discussing about agriculture, we are discussing about crops, because we need to eat and we need to survive. So, Dr. Jemana, please, the floor is yours now.
Thank you so much, moderator, and thank you to COSTECH for seeing the relevance of inviting a nutrition stakeholder to this meeting. It's unfortunate that often nutrition is implied and it has no owner until somebody understands that knowing food or cultivating food does not mean using of food. And so I'd like to start just by preempting the audience on what the nutrition status of Tanzania is as we reflect on science, technology, and leveraging on indigenous knowledge. At the moment, 30% of children who are under 5 are stunted. 3.5% suffer from wasting. We also have overnutrition in that 36.7% of women of reproductive age are overweight or obese, and 17% of our men are also overweight or obese. In addition to that, we also suffer from hidden hunger or micronutrient deficiencies, to the extent that 59% of children under 5 suffer from anemia, and 42% of women of reproductive age also suffer from anemia. What is the cause? There are several, but given that we're also discussing the food system, then we should also look at what is the food system providing to us or giving on our plates to the extent that we are undernourished or overnourished. Food is what dictates the dietary pattern. Culture and our biogeography dictate specific food-related habits. But if you look at all the literature that is available, the Tanzanian population is described to have a monotonous diet. Now, many of you will be shocked, what do you mean by monotonous? While if you look at your plate, you see carrots, you see ho-hos and the like. What this means is that 3/4 of our energy requirement is provided only by starchy foods. Starchy foods include cereals, tubers, and green banana. In 2023, the Ministry of Health published the Food-Based Dietary Guideline, and this prescribes that 36% of starchy foods should provide the caloric needs. How much calories does a normal average Tanzanian need? 2,300 kilocalories. Do we meet those needs? Does our food system meet those needs? Probably not. Now, why is it important to really look at indigenous knowledge? I think indigenous knowledge is able to provide us with a more diverse diet. If you look at the stunting rates, 30% is a national average. But regions that have a higher prevalence of more than 50% are regions that are considered the bread baskets. The southern highlands, what do they produce? They produce maize. But does maize give us the nutrition requirement that we need? Probably not. So what would be our advice as nutrition stakeholders? How can we make agriculture more nutrition sensitive as it plans and it considers and as it implements the roadmap for food security transformation by 2030? We need to be more diverse. Maybe we should think of bringing back the foods that made us who we are today. Where are our traditional fruits and vegetables? How many of us eat msusa, ngogwe, bamia? And do we consider these as diverse foods, or are we more obsessed with the high, dense, nutritious foods such as nyama choma, the chips and mihogo ya kukaanga? We need to reconsider our plate, make it more colorful, include more of the traditional foods. Can we have our young children snack on insenene rather than snacking on an ultra-processed sausage? My question to you would be, how can we go back to some of these indigenous knowledge, add value by including the science and technology that Professor Nduguru has stipulated, and make our plates reach that 2,300 calories that we so need in order to overcome the nutrition challenges that we have. Thank you.
Thank you very much, Dr. Leina. You have introduced the issue of our traditional food in Africa. I understand the majority of Africans does not understand that maize, rice, those are foreign crops. They are not traditional to Africa. This is a take-home message. We need to consider going back to our traditional foods. While we are taking this assignment, I know everybody is wondering, because in every village, everywhere in this country, we see people growing maize. Maize is not natural to Africa. Maize was brought from Mexico by the colonialists. Now our last discussant is Professor Joseph Nicolao Otieno. He's an associate professor in ethnobotany at the Institute of Traditional Medicine at MUHAS. He served as the director of the institute for the past 6 years, since 2018. And apart from that, he has a new appointment as the chairperson of the Traditional and Alternative Health Practice Council of Tanzania. He is involved in training, research, and consultants in traditional medicine, plant conservation, and plant biotechnology. So, Professor Otieno, the floor is yours now. You are welcome.
Thank you very much, Professor Malebo. And I thank the organizers for appreciating my presence in this session. As I'm coming from the Institute of Traditional Medicine, most of my discussions will be biased to indigenous knowledge. Towards the talk, the key talk by Professor Nduguru, we heard how they managed to do research on cassava, and then the results were brought down to the farmers, and we appreciate that we got high yields. My argument now comes in a complementary way by embarking on what farmers know, what indigenous people know. And I know that farmers' productivity is highly affected by the climate change. Local people, indigenous people, knows better how to predict weather, how to predict and assess the changes of the climate. When they look at the behaviors of animals, behaviors of insects, when they look at the songs of the birds, when they look at the celestial parameters, stars and winds and all that, they can tell what will happen maybe in a day, maybe in a week, maybe in the next year. This indigenous knowledge in predicting and analyzing the characters of the climate is not well captured in science. So within this sitting and this talk, I'm advocating for research in indigenous knowledge in assessing the climate change parameters. The other thing, in land races, as Professor Amisi said, most of the crops we are using today are not native to Tanzania. They were brought from outside the country. But again, we consider some to be native now, like sorghum, like millet. Even with maize, there are some that were introduced, but now they were naturalized, they become as native to Tanzania. They perform better in various climates, and we consider them to be native now. Though now, with as they bring new varieties, then those ones are being marginalized. But with this sitting today, we are advocating for land races. We should go for the native crops that can provide genetic makeup that can be bred with the modern crops to bring very resistant crops in the light of changing climate and weather. And the other thing that we can consider, you talk of phytochemicals. My institute is doing a lot of research in traditional medicine, phytochemicals. We do not bridge research in our institute with the TPRI. So it's the time now to make sure that the knowledge of indigenous people in terms of phytochemicals that they are using to control insects, viruses, and the other diseases should now be incorporated to the ongoing research, conventional research that is going on. We will get good results. The other thing is, seed collection. Dr. Mbwana touched on that. Seed collection. They have their knowledge in collecting seed and storage by using smoke. That one can kill diseases, especially infected seeds. So this indigenous knowledge, and by concluding, I could say We need to bridge. In our research, we need to bridge indigenous knowledge with modern science. It should be a paradigm shift where we bring these two disciplines together. We will come with hybrid that will help us to fight diseases, to ensure food security for our people. Thank you very much.
Thank you very much, Professor Otieno. Before we conclude, I would like to ask for any burning question or comment from the floor. Please be brief and to the point. We are running short of time.
Hamisi, you have only 3 minutes for that.
Okay, only 3 minutes. There is a hand. Only one hand, so we are lucky. There is a second one. Okay, let's start. Yes. Yes, please. Can someone help us with the mic to the speaker? Please introduce yourself and please be brief.
Okay, thank you. I'm Violet Ernest Mamba from Kairuki University. First of all, I would like to congratulate the presenters for such a wonderful presentation. My question is concerning the use of technology in the increase of crops production. Technology is good and I really encourage the use of that. But my question is, how do we maintain the quality, the origin of the seed while using technology? Because we can see in other countries, especially in European countries, organic foods are very expensive compared to other kind of foods. So it means organic is still valuable compared to those which are relying on technology. And we have seen here in our country, we have lost a lot of different crops, the taste and the quality in the name of technology. People are complaining, you get a very huge banana product, but when it comes to taste, storage, the quality is no longer the one which you used to have. So how do you address that? Thank you.
Okay, thank you very much. Let's take the second question before our experts get a chance to respond. Yes.
Thank you. My name is Akin.
Excuse me, madam. Let's give the microphone to the second person and you will be the last one.
Thank you very much, moderator. My name is Nuhu Hatibu from Africa Academy Limited. I've got first of all, I stood up to congratulate Professor Ndunguru for really very, very good work. However, bwana shamba wangu Professor Ndunguru anahangaika. Maziwa yangu yakiliwa na wadudu, analeta pesticide hii, anajaribu haifanyi kazi. Kuna uwezekano wa hii technology ambayo ni really very good kuwa mobilized iwe kwenye mobile tools like telephones, kiasi kwamba you can just take a photograph with your telephone na immediately the telephone will tell you exactly which pesticide to go and buy. Is it possible or are we already there? Asante sana.
Okay, asante sana. And then our last.
Thank you. My name is Akinyi from the Nelson Mandela African Institution of Science and Technology. My question is, why are these traditional medicine not prescribed to us when we visit the hospitals? It's like if you want them, you have to take them at your own risk, but the doctor will never prescribe them to you. some of them will actually tell you that we do have, from the traditional institute, they have the medicine, but they never prescribe it for you. Why is it not like taking all those process and put in the system like the other medicine? Thank you.
Oh, thank you very much. I think before I give the floor to the discussants, I can comment on the last question. Again, another take home to all of us. Please note that 80% of the medications you are being prescribed in a formal healthcare setting, they are derived from traditional medicine. So most of us, we are consuming a lot of traditional medicine which have been modernized. Then I'm leaving the rest to the discussants to comment.
Professor, please restrict the discussants. Time is over and over.
Okay. 1 minute to Professor Ndunguru, and then 1 minute to Dr. Bwana, and 1 minute to Professor Otieno.
Yeah, I would like to respond to Hatibu's question whether this device or this technology is portable. It is portable. You can use it in the backyard of your house. You sequence and it will give you whole genome of the insect affecting your animal, and from there you'll be able to get appropriate insecticide to address them. Yeah, so it is. Yeah, and we can help you to acquire them. Very cheap.
Okay, thank
you.
The
next, I think, is seed.
Dr. Bwana.
Thank you very much, the moderator and the Violet, for the question. We are actually very concerned and sensitive on the quality and the originality of the seeds. And that's why we have the recognition of the coexistence between the traditional seed and the modern or improved seed. How do we maintain that? Because we have to have the seed banks for the one which we want to keep. And we do have two types of seed bank. We have the community seed bank, where we deal with the farmers to make sure that what they have, they keep on their vicinity. But again, the duplicate is kept at Itari and at other seed banks around. But also, when we are impressing on the technology, we are also very much keen to make sure that we have enough isolation distance to make sure that there is no gene flow from the modern one to the original one. So don't worry about that. Everybody needs to have what she or he wants to have. And that's why we have both the traditional seeds and again the improved one. Asante.
Okay, Prof. Otieno, thank you. And Gelmana will be the last.
The question as to why traditional medicine are not prescribed in health facilities, this has started. For most of the registered herbal medicines now are being served at the government health facilities, especially for registered ones. You will find them there.
And Dr. Gelmana, 1 minute, please.
Thank you so much. I think my take-home message would be, can we all always consider that the science and the indigenous knowledge that we use at the end of the day should be for the benefit of our well-being and in particular our nutrition status. Thank you.
Yeah, thank you very much. I would like now to return the rank which I was given by the chair back to him so that it will continue with the next session.
Thank you very much. Thank you very much, Professor Malebo. This marks the end of the two keynote papers presentation. Would we give one round of applause, please? And I think you can go back to the seats. And if you look at your program, we have one presenter called Masatu. I don't know where he is. Masatu? Yes. Masatu is known as an innovation analyst from the United Nations. He's going to give a very brief talk on the state of the fintech policy and regulatory environment in Tanzania. Very quickly, very brief, time is over. Please, Masato karibu. As Matatu is getting forward, may I remind you that when we finish this, we are going for the breakout sessions, as it appears in the program. One of the sessions will be here, the other session will be in the Ruaha Hall. The organizers might show you this, and the other one will be at Mikumi. Masato, are you ready? You are still applauding, okay. Will you take very, very short time? Probably not more than 10 minutes, if you can, please. So while Masato is applauding, can we have the organizers telling us where are these two rooms? Nani anayetuambia Ruaha iko wapi na Mikumi iko wapi? Kwa sababu seluzi ni hii tuliopo. Yes, karibu.
Asante daktari. Ukumbi wa Ruaha upo upande wa kushoto. Ukitoka kwenye mlango wa nyuma hapa ukielekea kushoto unaona ukumbi wa Ruaha. Na ukumbi wa Mikumi yuko first floor upande wa kulia.
Wakati bado ana upload nimekumbushwa tena kuna yule mtu aliyeacha ile gari wazi. Vile vitu vitaibiwa ise. Quickly kimbia kule nje, bado madirisha yako wazi, kuna vitu vinaonekana ndani vinavutia watu. In some few minutes you might find those things missing in the car. Make sure you manage the car, please. The number is 439 EHB. Registration number ya gari ni 439 EHB. Naona kama kuna mtu anatoka mbio kule. Sio yeye. Kama gari hiyo ni ya kwako jamani, gari iko wazi, kuna vitu vya thamani, watu wanavitamani. Make sure you are there to manage the car. Masato, how far are you? Done? You can also take some few minutes to say who you are, where do you come from, and what do you want to talk about it.
Great. Good morning, colleagues. My name is Edgar Masatu. I'm from the United Nations Capital Development Fund, a UN agency mandated to work with stakeholders on trying to increase access to finance and financial services. In Tanzania, we invest in clean cooking solutions through our Cook Fund. We work with local government authorities to improve and enhance their capacity to adapt to climate change. We invest in SME and startups through the Funguo Catalytic Fund. We support through the Digital for Tanzania project funded by the European Union. We support growth of the fintech sector, and this is what I'll talk to most about this morning. So I have 10 minutes. I'll fly quite quickly. So fintech is integration of technology in delivering and use of financial services. It's largely around 6 categories, around payments and remittance. So your mobile money is here, your Nalas or Western Union is around remittance. In credit and lending, so your Songesha, Empower, Timiza, Liner Finance falls under this. In accounts and savings, in investment facilitation, where you're utilizing technology to make investments for personal or business use, in provision of insurance, and also in e-commerce, purchasing and paying for services. So globally, this emerging sector is growing at an annual, compound annual growth rate of 14%, However, investment in this subsector is shrinking. We are seeing good performance in fintechs from the MENA region, and payments globally are the most dominant fintech segment globally. In Africa as well, there is growth of this sector with about over 1,000 such companies. However, investment is dwindling in this space, and most goes to the 4 countries of Kenya, Egypt, Nigeria, and South Africa. In Tanzania, matching with the global trends, payment space has more operators, followed by credit and lending space. However, these fintechs, which represent almost half of the startup ecosystem in Tanzania, despite their revenue growth, they are finding hard to raise resources, and these are some of the areas that are posing a challenge for attraction of investment. So one, as a market, we do not have a fintech regulatory policy. As such, fintechs are regulated by multiple regulators, and this poses a cost challenge for businesses of this size to register and expand. In terms of the cost, the licensing cost is similar to the traditional financial institutions, so banking and microfinance. As well as for those who've raised funding, the recent dollar scarcity meant that they were paying at a higher cost their debt and equity instruments. For digital expansion of the financial inclusion, having national ID uptake being lower is an issue, as this is the #1 KYC, know your customer verification information. However, we've noted that the recently introduced Jamii Stack with Jamii number will come and support this area. So also we've noted that regulators are being proactive in trying to provide regulations around fintechs. So we have the Bank of Tanzania recently launched Fintech Regulatory Sandbox. There's a plan to establish a national venture fund. The Capital Market and Security Authority is developing operational guidelines for venture capital and private equity funds to operate in Tanzania. In Zanzibar, they drafted the Digital Transformation Policy and Investment Policy has been drafted. Bank of Tanzania has established a National Cryptocurrency Technical Committee. This will support the bank in supervising the digital currency to protect citizen digital currency transaction. There is also, through the Jamii number, efforts to expand national ID coverage, especially for rural communities, and having a digital identity from birth. There are plans for Startup Act, but also potentially financial regulations. So what are the areas where, based on this study, we see there is room for Tanzania to take a leap and be competitive in attracting investments for fintechs and startup. So one is around registration and licensing. The current registration framework for fintechs is a bit complex. There's room to improve this through potentially governing, having a super regulatory body governing this space, which is a case in South Africa. Also, because fintechs are required to acquire expensive licenses quite early on, there is room to have a tiered licensing framework to support the early stage startups. And an example here we've provided, imagine a fintech that is using the mobile network infrastructure, is supposed to comply to a regulation that has been developed to supervise the said MNOs.
Can you wind up, please?
Yes, I'm almost on the last slide. So again, yesterday, a colleague from University of Dar mentioned the IP framework and its challenges. The issue is similar to the fintech space. So these are the key recommendations that could further improve the fintech enabling ecosystem. We have a continental framework for data security. So if this is implemented, the fintechs are able to utilize servers to store data in East Africa or across Africa. In terms of e-money restrictions, a tiered licensing for small and large money issuers is recommended. In terms of the costs and the threshold for notification to regulators on merger and acquisition, we are recommending increased merger acquisition threshold given the asset type of the fintechs and reducing of the fee for such notification. Also, two final recommendation is really clarifying the process for establishing venture capital operations in the country and other investment vehicles, as well as creating an incentive for the said venture capital investment and PE investments to invest in Tanzania long term. So a trusted investor program is recommended. For these recommendations, if onboarded, are set to improve the operating environment for the fintechs in Tanzania and make Tanzania competitive in attracting investment across Africa. I submit. Thank you.
Thank you very much, Masatu. Unfortunately, we are not going to spare any time for discussion because the time is no longer with us. I can advise whoever is having any reaction to Masatu's presentation, you can see Masatu somewhere in the corner in the
Niambie watu waingize.
Hello, my name is Wilbert Manyelizu from COSTECH, moderator of this session. I would like to ask 4 of the first presenters to submit their presentations here so that I can call the first presenter to start. Thank you. The presenters for the first session Juliana Machue, Joram Girangwa, Joseph, Lawrence Keref. Please submit your presentations so that we don't waste more time. We have only 1 hour for all 8 presenters to present, and everyone must be attentive and effective time manager. Only 10 minutes for each presenter. Yes, then the last one atakuwa Joseph, where is Joseph? Joram. Joseph, please. Yeah, we have Joram already here and the Kerefu. We are waiting for Joseph to submit the presentation so that we start. We have mainly 2 objectives to achieve in this session. One is to ensure that we describe the relevance of our presentations in connection to questions and answers, so that we address the application of science, technology, and the innovation we are interested in. That's one objective. The second objective is to be effective in time management so that we don't miss our lunch, because the lunch time is fixed. And if we delay, I hope we know the consequences of missing lunch. Thank you. Joseph, please. Thank you. In order to achieve, especially the second objective, I request you to assist me, to support me in managing time. Strictly be effective manager. Only 10 minutes for presenters. Only 10 minutes. And I will be the moderator and timekeeper to make sure that we don't get late, especially for food. Thank you. I give this time to first presenter, who is Joram. I'll ask you to introduce yourself by name and where you are coming from, if you are interested in the qualification, so that the audience can jot down for specific questions to you.
I will start with the introduction, methodology, research questions, discussions, action, methodology, research questions, discussions, conclusions, and finally recommendation. Yeah, the introduction, it is actually highlight the main task of the higher learning institutions, that is, apart from teaching and other activities, another core important function of the higher learning institution is conducting research in various disciplines. So these research outcomes should be translated or should be transformed from higher learning institution to the society, so that the society can benefit directly from what is being developed from higher learning institutions. So the aim of this study is to analyze and synthesize some issues related with the practice and the mechanism of technology transfer from the university to higher learning, from the university to industries, and specifically SMEs. And by doing this research, the following research questions should be addressed. The first research question is, what are the research landscape of the published papers on the research topic? The second is the concentration area for the published paper over the past 10 years. And lastly, what are the opportunities that our country, or as a Tanzanian higher learning institution, can benefit from those research papers. Now, the methodology of this research is the use of the preferred report item for systematic literature review and meta-analysis. Simply, we call it PRISMA. And this PRISMA will be adopted by following the following search strategies. That is, starting with the search item and the keywords, eligibility criteria, screening and the selection process, studying selection and the data extraction, quality assessment, and finally with the data analysis. Now, this PRISMA methodology will be guided by some exclusion criteria that will be followed for all papers that are being extracted. The result of the PRISMA indicates that a number of papers are being developed in 2017 regarding the technology transfer from university to industries. But also, these papers are being concentrated highly on the university technology transfer. And all these papers, if we are being distributed in various continents, as we can see, more papers are being concentrated in Europe, followed by Asia, South America, and we can see a lot of publications are being published regarding the African continent. Now, under the discussion, it has been already observed that from all reviewed papers, it indicates that more papers are being developed on technology transfer in the European continent, and also more efforts are being indicated that African countries need some more understanding and impactful effort to be done on the university industry technologies transfer, and to know its dynamics in the local context, especially when focusing with the technology transfer to SMEs. The paper concentrations, these papers, most of the papers concentrated on the technology transfer from university to large industries, leaving behind SMEs and micro industries that most of our locality are dealing with. So under this, there is a clear gap that exists between the higher learning institution and the industries, specifically SMEs. So what is the opportunities that Tanzania will gain from it? This indicates that most of activities are being conducted, or our research output which are being conducted focused to solve the problem that is facing the society, or if it is an engineering problems, we expect that those problems will be solving an engineering issues relating to the society, and most of the societies around engineering issues are SMEs and the micro industries. So by conclusion, it is been observed that there is a weak collaboration between the university and the industries, and in this case, SMEs, and also there is a mismatch of institutional objectives and the priorities of the higher learning institutions as well as the SMEs, but also there is inadequate institutional support mechanism which will enhance the technology transfer from higher learning institution to SMEs. On another side, the literature indicates that there is a need of more effective mechanism for disseminating knowledge and the technologies that are being generated in the higher learning institutions. The recommendation of the research, it needs some issues to be done so that they can strengthen the linkage or technology transfer between the higher learning institutions and technology transfer. The first one is for those higher learning institutions which have no technology transfer office or centers, they should establish that center so that they can link the technology transfer between the higher learning institution and the SMEs. But also creation of some of collaborations or platform between higher learning institution and SMEs, but also developing the fund mechanism and incentive structures that will tend to motivate researchers to engage in research and how they can commercialize their research findings, but also proper management of intellectual properties, and finally improve the dissemination of knowledge and the technologies generated between the higher learning institution and the SMEs. Thank you, in advance for your effective.
Thank you very much for keeping time, for being an effective manager. I hope universities and other high learning institutions are doing a lot about technology development and transfer. Now, are they able to transfer to the ACMC, or they are just getting research questions out of the need? Second presenter, please, take your floor. Your audience need to note down the name of the presenter and the question briefly, so that when the panels come in front, you can specifically focus your question to whom it's addressed to. Second presenter, please. Joseph. And the third presenter, be ready. As he finishes, you come in. Thank you.
Joseph.
Nyoni.
Yeah, naomba nikuuze kabisa hiyo kubwa. Naomba nizumue kabisa hiyo kubwa. Hizi pieces zipo tofauti. Unasije kwa hapa hivyo ndo nani? Kwa namna wanaizoom inaonekana pale kubwa. Hapa hivi. Okay. Good morning. My name is Engineer Joseph from Tanzania Agricultural Research Institute from Department of Agriculture Engineering. I'm here to present a critical review on the improvement of round potato productivity through the use of simple planters in potato growing community in Tanzania. The content of my presentation is, there is abstract, introduction, problem statement, methodology, evaluation of literature studies, discussion, conclusion and recommendation. This presentation explores the potential of simple planters to enhance round potato productivity in Tanzania. And the review, based on evaluation of the potential of the simple planters in the potato growing region in Tanzania, as it highlights how traditional manual planting method characterized by high labor intensity and inconsistent seed placement. So some studies reporting the gain of 20 up to 40%. And the evaluation identifies the key challenges such as limited adoption of the planter due to high costs and the inadequate farmers training. So these efforts are critical in the improving of food security and the livelihood of potato growing community in Tanzania. Potato is staple crop in Tanzania which contributing to food security and income generation. Farmers face challenges such as low productivity and the labor-intensive planting practices. So objective of this paper is to evaluate the potential of simple planters to improve potato farming productivity in Tanzania. Problem statement. The low potato productivity in Tanzania is limited by many factors, including poor planting method and the lack of mechanization facilities. This leads to farmers lose about 30% of planting population, depending on planting method used. So this review intending to show the potential of simple planter in potato growing community in Tanzania. The methodology of this review follow these approaches. The first one, it is reviewing of scientific journals, agricultural reports, and the case study focusing on mechanization and potato farming. And another one, it is the field observation of observed planting practices in potato growing region in Tanzania, so as to understand challenge faced by the farmers. The inclusion criteria of this study, it depends on studies focused on potato farming and mechanization, and the exclusion criteria is studies unrelated to potato farming or mechanized planting. The evaluation of the various literature. The key issue here is comparison of traditional and mechanized planting method, as it shows that mechanized planting method give good labor efficiency, proper time management, and the key design discussed in various literature is manual, animal drone, and the simple mechanized planters. Also, the trends, the increasing interest in low-cost mechanization for smallholders farmers, innovation in locally manufacturable plant design. That is the example of pictures of potato planter and its components. Also the models of various planters. On the point of discussion, the key benefit observed, it's good productivity and efficiency of the planter. Planters reduce labor demand, especially for women and youth, increase the profitability for smallholders farmers, and the barriers are financial constraint, limited access to planters, resistant to change due to traditional farming practice, and inadequate extension services. Conclusion and recommendation. The key lesson here is simple planters have significant potential to improve productivity and sustainability in potato farming. And the adoption of these tools can enhance smallholder farmers' livelihood and food security in Tanzania. So, recommendations, we have to develop locally adaptable planter models and to establish partnership between government and NGOs. Also to conduct a pilot study to demonstrate the benefit at the community level. This is an example of reference. Thank you.
We forgot to clap for the first one. So thank you very much for keeping time. Now it's time for the last presenter for the first round before we go to the second round for the last 4 presenters. Please, the third presenter, you're welcome. We can see the academia is busy developing technologies and transferring the technologies. The community and the industry is also waiting for these technologies to use. Where is the rink? We need to prepare the questions so that we make relevance of our presentations to the society problems and also to the industry. Karibu.
IT, kale kakalai kanafichika hapa kwenye laptop yako. The IT person should be very close here so that we don't waste time. Kale kanafichika hapa. Kale kakalai kanafichika hapa, kanajificha hapa. Kale kakuonyesha slide. Kakuonyesha slide hiyo pana yote. Yenyewe tu.
Good afternoon. My name is Lawrence Kerefu. I'm a lecturer from Dar es Salaam Tumaini University. And I'm going to talk about exploring the effectiveness of commercialization pathways for university research output in Tanzania. This is my co-author is Dr. Juliana Machuve. Let me take also this opportunity to congratulate the presenters who presented today and also those who did the good presentations yesterday. My layout will be introduction, methodology, results, discussion, conclusion, and recommendations. So with the introduction, all we know that the society expects university to produce knowledge, technologies, and inventions as output. But also, we expect the industry to turn the output into products and services that drive the economy. That's why every now, when we are talking about innovation, when we are talking about commercialization of university research output, we are always talking about the link between academia and the industry. And this process now depends on the suitability of the universities to generate such knowledge, technology, and inventions, and the existence of mechanism for sharing or transferring the generated knowledge into the society. With this figure, what I just said, you can see on the left side, you see the side of the society and the industry. The society and industry are having needs and the problems. And then at the middle, that is where we have universities. At the university, their main function is teaching and learning, research, innovation, entrepreneurship, public engagement, and partnership. Then from this, we expect now, at the end, we have graduates from universities, we have innovators, but also we expect to have solutions to problems of the society for having a better living, but also prosperous industry. So this is the relationship. Now the link we are talking about is how to have the needs of the society, the needs and problems of the industry to be transformed into better living and prosperity. This, we are talking of, even yesterday we have said that we need to have solutions. But what kind of solutions are we looking for? Universities are expected to see the society problems or the challenges of the problems or the needs of the problems, identify these needs, and come up with innovative solutions, not just mere solutions, but innovative solutions. And these innovative solutions must have someone who is willing and able to pay for the solutions. So the researches that are being conducted at the universities must relay or must agree on this principle that there must be somebody who is ready to pay for the solution. And I'm talking of not the basic research, but I'm talking of the research that we are talking, the developmental research, which are geared to solve problems of the society. So in this one, you can say at the top there, I said you have to connect academia to humanity initiative, the CAH. There must be that relationship. What the students are being taught at the university must relate at the end of the day to the solutions that are facing the public or the society or the industry. I used to tell my students that at the society we have enough problems without you. So we don't need you to graduate and to add again these problems to the society, but we need, when you graduate, to become problem solvers, to become innovators. Now, the objective of the study was to explore the effectiveness of commercialization pathways for university research output in Tanzania, and intend to come the university to produce impactful research that have economic value for the community. The research methodology, we collected data from 11 mostly engineering-based universities, and 2 of the surveyed universities were from the private sector, and 9 were from the public universities, and 1 from, among these 9, 1 from the Zanzibar. We also interviewed directorates, head of directorates, and head of departments who are responsible for research and innovation activities at the participating universities. Results and co-discussion. The first item of commercialization, the status, we observed that the type of research output that the universities have developed for the past 10 years, this is what we observed, and the results indicated that there is a predominant research output in the form of research and innovation reports, paper publications, followed by prototypes and innovative products, processes, and services. As also there are policy briefs and software, as can be seen in this graph. This is what we have seen, the research output for the participating universities for the past 10 years. You can see a lot of research reports. You can see publications, policy briefs. You can see prototypes. These are the kind of research output that we have seen, or we have been briefed when we were surveying the universities, 11 universities. Now, we also noted that only 33% of the participating universities claimed that their research output are above average, with an extent of commercial potential ranging from 51 to 100. And only 9% of the participants have realized the commercial potential, and the research outputs to the level of commercialized products, that is, they are already in the market. And this, you can see in this graph here, the 33%, the one with the very high potential and very high potential and high potential. But you can see the moderate potential and low potential and not at all potential. And this is potential for commercialization. Now, we also asked about the commercialization pathways that they are pursuing. You can see they're talking about outright sales, licensing, spin-off companies, technology transfer offices, incubators and accelerators, industry collaborations and partnership, which is already being said so many times, and joint research and development, that is R&D agreements and startups. So the participating also university indicated several reasons for selecting particular commercialization pathways, including available resources, market demand, competitive landscape, time to market, collaboration opportunities, competences, experience, ease of doing business, and the university's innovation and entrepreneurial culture. And this is the extent of utilization of commercialization industry collaboration, joint research is following. Licensing and speed of companies are marking very low. So